Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called The One and Only Sum by Lithium Ion, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We have cells separated by a black dot contain digits that are in a 1 to 2 ratio, and cells separated by a white dot contain consecutive digits. These are considered Kropki dots, or they're named Kropki dots. So as an example, if we had, say, a 2 here, this would have to be 1 or 4 to maintain a 1 to 2 ratio between them. And if we had, say, a 6 here, this would have to be 5 or 7 for these digits to be consecutive, because there's a white dot between them. We have neighboring digits along a green line must differ by at least 5. I call these Whisper 5 lines because the setter came up with that name. And I thought it made a lot of sense because it's very easily extensible. Other people call it German whisper lines. And we have neighboring digits along an orange line must differ by at least 4. I call these Whisper 4 lines. Obviously, there's the extension, right? You can call it Whisper 5 and then Whisper 4. You could have Whisper 3, Whisper 2. Other people call it Dutch whisper lines. As an example, say we had a 3 here. Then this would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. If we had 3 here, this would have to be 7, 8, or 9, because the only digits which are 4 or more away from 3 are 7, 8, 9. Hence Whisper 5 and Whisper 4 lines. A pink line contains a set of non-repeating consecutive digits in any order. This is also known as a Renban line. So for an example, you could have something like, say, 6, 8, 5, and 7, and this would be valid because these digits form a set of consecutive non-repeating digits. You cannot have something like 5, 6, 7, 9, because 9 is not consecutive with 5, 6, or 5, 6, and 7. So that doesn't form a set of consecutive digits in that case. Along a gray thermometer, digits must strictly increase from the bulb end. This is known as a thermometer. So you could have something like, say, 2, 4, 5, 7, 8, 9. And this would be valid as a thermometer because it's increasing from the bulb to the tip. What you could not have, though, is something like, say, 2, 6, 5, 7, 8, 9, because it's decreasing from the 6 to the 5, and you can't decrease ever on a thermometer. Each set of 3 consecutive digits along a peach entropic line must contain 1 low, 1, 2, or 3, 1 medium, 4, 5, and 6, and 1 high digit, 7, 8, and 9. So we could have something along, so this is for any set of 3 consecutive digits on this peach entropic line. We could have something like, say, 5, 2, and 7 here. And this would be valid for this portion of the line, because for this portion of the line, we have 1 low, 2, 1 medium digit, 5, and 1 high digit, a 7. So that's an example of how entropic lines works. Box borders divide the blue region sum line into segments with the same sum. So for example, this blue line is divided into segments, I should say. We have a segment here, a segment here, segment here, segment here, and then a segment here. And those must all sum to the same sum. So that's how region sum lines work. And The sum of all digits that belong to one constraint type, for example, all digits on the black dots, is the same for each of the 8 constraint types in this puzzle and must be deduced by the solver. The sum of all digits that belong. Okay, so for example, you have digits that are only surrounding black dots. You have digits that are only surrounding white dots. Excuse me. You have all digits on the whisper 4 line. You have all digits on the whisper 5 line. You have all digits on the entropic line. My throat is really dry right now. I don't know why. And all of them, so all the digits per rule set must sum to the same sum. So all the digits next to a black crop key dot must sum to the same sum. All the digits in a white crop key dot must sum to the same sum. All the digits on the thermometer must sum to the same sum. All digits on the whisper 5 line must sum to the same sum, as must the whisper 4 line, as must the entropic line, as must the Renban line, and as must the region sum line. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. So, we have all these digits on these, in each type of rule set have to sum to the same sum. So we need to sort of figure out the boundaries that we can have for the smallest amount possible that satisfies every rule set and the largest amount possible that satisfies every rule set. Well, for a Renban line, we have only 4 digits. I think that's the one that's going to be the most restrictive. Everyone else has 5 or more digits, except for the Kropki dots. Excuse me. But the Kropki dots could have repeats. The Renban line cannot. So the most we're going to have is 4 digits here, which add up to the same, which add up to the most you can have, which would be 6, 7, 8, 9. So the maximum our sum could be is 30. Because if it's greater than 30, this Renban won't satisfy it. Okay. What about what's the guaranteed minimum for any of these digits? We have here, these 3 digits must sum up to the same sum. And on top of that, you have 3 unique digits adding up to whatever this digit is. So this digit must be the same as that digit, which must be the same as that digit, because again, these are segments by themselves, and they must be the same sum. Well, that adds up to 3 unique digits that must add up to it. And 3 unique digits adding up to a single digit has to be at least adding up to 6, right? Because you have 1, 2, and 3 as unique digits. That's the minimum you could have. That adds up to a minimum here of 6. So we have 6 here, 6 here, and 6 here at minimum. These must add up to 6, and these must at least add up to 6. And that adds up to 30. And that's the minimum this can be as a set. So we know then that since 30 is the minimum for this region sum line, and 30 is the maximum for this Renban line, and all of these must sum to the same sum, then the sum has to be 30. And then this has to be 6, 7, 8, 9. These single digits have to be 6. So this is 7, 8, 9. We have 6, 7, 8, 9 here. Obviously no 6 here. This must be 1, 2, and 3 to add up to 6 here. And this must be either 1, 5 or 2, 4 adding up to 6 for the region sum line. This pair of digits cannot have 1, 2, or 3 involved. The only combinations you could have, again, are 1, 2, 2, 4, 3, 6, and 4, 8, but 1, 2, and 3 eliminate 3 of them, so we're left with 4 and 8 here. That leaves the remaining digits in this box as 5, 6, 7, and 9. Well, which digits here are 4 apart from each other? The only ones that satisfy it are 5 and 9. That eliminates 5 and 9 in the rest of the box. So this is a 6, 7 pair. This is already 14 here. So the remaining digits in this Whisper 4 line have to add up to 30 minus 14, which is 16. Here, what can we have? We cannot have 1 and 2 because that would eliminate all possibilities for this pair here, adding up to 6. We cannot have 3, 6. So this is either 2 and 4 or 4 and 8 in a 1 to 2 ratio. And one of these is therefore 4, which eliminates 4 in the rest of the row. So this cannot be 2, 4. It's 1, 5 as a pair. Guaranteed. So that eliminates 1, 5 in the rest of the row, so no 1 there. 6 and 7 eliminate 6, 7 in the rest of the row because of the 6, 7 pair. 6 eliminates 6 here. So the remaining digits that could be here, no 1, 5, no 6, 7, so it's 2, 3, no 4, it's 8 or 9 as possibility. This is also a 1 to 2 ratio here. Without 1, 2, 3, or 6 available, that leaves us as 4 and 8. So 4 and 8 add up to 12. This adds up to 12 too, that's 24. So these two must add up to 30 minus 24, which is 6. So this is a 2, 4 pair, which eliminates 2, 4 in the rest of the row. So this can't be 2, it's 3. No 3 here. No 2 or 3 here. This is 8 or 9, 8 or 9 there. Remaining digits of column 3 are 5, 7, 9. Well, for every 3 digits on the entropic line, you have to have 1 medium, 1 low, and 1 high. We cannot then have, if this were 5, this would force us to be 7, 9, and 7, 9, or 7, 9 in some order, which would be 2 high digits next to each other. So we don't have, in that sense, 1 low, 1 medium, and 1 high in this set of 3 if that were the case. So this cannot be 5. It's definitely a high digit. These are medium and high digits here, which means we have to have a low digit with it. So this must be 1, 2, or 3 there. For this set of 3 digits, this is either medium or high that we're losing here. So this must be medium or high. Cannot be 5, 7, or 9. So it has to be 4, 6, or 8. Same with this. This is losing a low, medium, or high. So this must be, again, 4, 6, or 8. And we have to have a low here, because these 3 digits don't have a low. So this is 1, 2, or 3. Okay. So we have a guaranteed 5 here. So we know these 6 digits add up to 30. So the remaining digits in the box have to be adding up to 45, which is the sum of the digits 1 through 9, which are all the digits in the box, minus the 30 that must be on the entropic line here. So this must add up to 15. 45 minus 30 is 15. We don't have a 6 here. So where is the 6 in this box? It has to be here. And we have a guaranteed medium here as a 6. So this can't be 6 here. This is 7, which makes that 6 there. So we have a 579 triplet here. We have a 579 triplet here. Where's the 579 in column 2? It has to be as a 579 triplet here, which leaves this as 1, 2, 3 there. So what are the remaining digits in column 2? Or sorry, yeah, column 2. It has to be 1, 2, or 3. So since this is a medium here, it's a 6, we have to have a high next to it. Because if we have two mediums here, then these three cells cannot have a low, a medium, and a high digit. So this must be a 6-8 pair. That leaves this as a 4. So these three digits, again, must add up to 15. The only way that works is you have 2, 4, and 9. 7 doesn't work because it would be 7, 4, and 4. So this has to be 9 here, and that's 2. That eliminates 2 in the rest of the column. No 9 here. It's 5, 7 as a pair. 6, 8 as a pair. Here, the digits that are 4 apart from each other cannot be 7 and 9. It has to be 5 with 9. So that means 5 and 9 here, which makes this not 5 or 9, it's 7. And this is 14 and 14 here. That adds up to 28. 28, 30 minus 28 is 2. So that's 2 there. That eliminates 2 in the rest of the box. 2 cannot be next to 5 on a whisper 4 lines. There are only 3 apart. So therefore, this must be 9 and 9, which makes that 5 and 5 there. So we have the whisper 4 line set. We have the entropic line set. We have the Renban line set. We have the region sum line set. We have the black Kropke dot set. So we still need to do thermometers, white Kropke, and the whisper 5 line. Okay, 9 eliminates 9 here. Remaining digits of row 7. We have 1, 3, 5, 7, 8 as possibilities. 7 on the the remaining digits of column 9 are 1 through 5. No 5 here, no 2 here, no 5 here because of digits already in the rows. Where is 7 in column 8 then? It has to be one of these 3 cells. Where 6 in column 9, it has to be one of those 2 cells. That eliminates 7 in the rest of that box, so no 7 there. 6 can't be here, so 6 is one of these 2. On a whisper 5 line, you'll always alternate between low digits and high digits on a whisper 5 line, and 5 can never be on a whisper 5 line. The reason why we know that is subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. So that's why 5 can't be on the line. For alternating between low and high digits on a whisper 5 line, low digits being 1 through 4 specifically, not the same as the entropic lows, and 6 through 9 on the highs, not being the same as entropic high digits. But you'll alternate between 1 through 4 and 6 through 9 on a whisper 5 line. And the reason why you know that is what digits can be next to a 1 through 4 on a whisper 5 line. Well, 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, and 4 can only be next to 9, all of which are the digits 6 through 9, which are high digits for the whisper 5 line. And then the same thing occurs for the digits 6 through 9, which are the high digits for the whisper 5 line. What digits can be next to those? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So you'll always alternate between a low and a high digit on a whisper 5 line. So the question is, how does this work here then? Here, Can we have low, high, low, high, low, is what I'm thinking. If that's the case, we could have 3 lows here, and we could have 2 highs. The 2 highs would be at most 8 and 9, which is 17. And the 2 lows here can be at most 3 and 4, and then we could have a 4 there. But 3 and 4 is 7, plus 17 is 24, plus 4 is 28 at most. So if we had a low, high, low, high, low pattern, then that would be too small to sum up to this 30 that we need for all digits in this rule set. So therefore, this must be high, low, high, low, high. This can't be 6. So what do we have here? So this is 7 through... Okay, cannot be 6 or 7 here. It's 8 or 9 as a high. Because we have a 6... We already have 6 and 7 guaranteed to be here in column 9. That means we have a 6, 7, 8, 9 quadruplets in this box, which eliminates 6, 7, 8, 9 in the rest of the box. So this can't be 8 here. 6 is a high, obviously, for the Whisper 5s. Remaining digits of this box, then, are 1 through 5. 1 out of 7 or 8 in row 7 has to be one of these 2 cells. So that means we're guaranteed, first of all, a 9 here, and then this must be the other 7 or 8 for the high. So we know this is a 9. We know that's a 9, so this cannot be 9 here, because one of these is a 9 there. Also, we have a guaranteed 7 or 8 here, because it can't be here in row 7. So that eliminates 6, 7, 8, and 9 in the rest of this central box, or this lower central box, because we have a guaranteed 7 or 8 here. One of these is 7 or 8, and the other one must be 9, and we already have a 6 here. So that leaves 1, 2, 3, 4, 5 as the remaining digits in the central box. We know this is 1 through 4 as possibilities here. Okay. So then this must add up to 30 also. Can we have a 4 be here? If we so this digit is the same as that digit, so maybe we can mark that as both orange. That satisfies sort of the red also. 2 and 4 eliminate 2 and 4 in the rest of this box. So 2 and 4 in column 9 both have to be here in this column. Okay. If this was 4, we would guarantee a 9 here and a 9 here. 4, 9, and 9 add up to 20. I think that should be fine. Let's look at these white crappie dots. Can we ever have 1 and 2 be part of this? And I think the answer is no. 1 and 2 is at maximum, well, it adds up to 3. And then the other 2 digits can be maximum 17, and that gives us only 20 for these white crappie dots. So that doesn't work. 2 and 3 doesn't work. That's 5 plus 17, 22. 3 and 4 doesn't work. 3 and 4 doesn't work. That adds up to 7 plus 17, 24. 4 and 5 also doesn't work. That gives us 9 and 17, 26 at most. 5 and 6 doesn't work. That's 11 plus 17. So in these white crappie dots, you have to have at least 6 through 9. And this can't be 6 here. So we're guaranteed one of these, one of these digits has to be consecutive. Well, we have an 8, 9, 8, 9 pair now in column 7, which eliminates 8 and 9 in the rest of the column. So this can't be 8 or 9, it's 7, and 8, 9 is not consecutive with 7, so this must be 7 and 8. That eliminates 8 there, so this is a 9. That's the same as that digit, so that's a 9. Where are 9 here means this can't be 9 here, it's 8. That means this can't be 8. Seven is here, 8 is here. So this is either 6, 9, or 7, 8 adding up to 15, plus 15 adding up to 30. Okay, so let's go along this long thermometer and try to figure out what they can be. So what I'd like doing with long thermometers is looking at the bulb, going to the tip, looking at the smallest possible digit, then going back from the tip to the bulb, looking at the largest possible digit, and filling out the cells that way. So this could be 1, because that's the smallest digit. This cannot be 2 because of 2 in the row, and it has to be greater than 1, so this must be at least 3. This is greater than that cell there, so it's 4 at least. This is greater than that cell, but cannot be a 5 because of the 1-5 pair in the box. So this is 6 at least here. This digit has to be greater than that digit, so this is at least 7. And this digit has to be greater than that, but can't be 8, so this has to be 9. Which means this is, since this is the minimum, it also has to be exactly what it is. Well, not exactly. Maximum is 9. This can't be 8 because of 8 in the box, so this is maximum of 7. So this has to be 9. This has to be 7. This has to be 6. This does not have to be 4, though. It has to be less than the 6. But it could still be 5 here. This could be 4, less than that. This could be 3, less than the 4 and the 5. So the question is, how does this add up? Well, we know these 3 are guaranteed to be 6, 7, and 9. Remaining digits in this box, then, are 2, 3, and 4. 7 eliminates 7 here and here. 6, 7, and 9 add up to 22. So these 3 digits must add up to 8, and they're all unique. So it's either 1, 2, 5 or 1, 3, 4 adding up to 8. And so this must be then 1, 3, and 4. 3 and 4, 1 eliminates 1 here, so that's 3, which makes that 1. No more 1 here, no more 3 or 1 there, no 3 or 4 there. We have a 1, 3, 5 triplet in column 9, which eliminates 1, 3, 5 in the rest of the column. So this becomes a 2, 4 pair here. Okay. 6 and 7 eliminate 6 and 7 in the column, so this is 8 or 9. Oh, 6 and 9 is not consecutive with each other. So this has to add up to 15. It has to be 8 and 7 there. 8 eliminates 8 here, so this is 9, which eliminates 9 there, so that's 7. That eliminates 7 in the rest of the box. So where is 7 in row 7? It has to be here. So no 7's here. This can't be 9. This is a 6, 8 pair. 7 eliminates 7 here, so that's 5 and 7. So this is a high digit according to the entropic lines. This is a middle digit, this is low. Therefore, for this set of 3 digits, we have a low, we have a middle, we need a high. So that's high, which makes that middle there. So this is 8, and that's 6, which makes this 8 and 6 there. We have 7, 9, and 9 here. 9 and 9 is 18, plus 7 adds up to 25. So these 2 digits must add up to 5, which is 30 minus 25. This digit cannot be 3 or 4 because it's next to a 7 on the whisper 5 line. And this can't be 4, but again, these 2 digits must add up to 5. So it's either 1, 4 or 2, 3 here. And 4 can't be here because of 4 in the column. So this is 3 with 2 being there. That eliminates 3 and 2 in the rest of the box. 2 and 3 eliminate 2 and 3 here, so it's 4. So no 4 there. 2 eliminates 2 in the rest of this row here. 5 eliminates 5 in the rest of this row here. 3 eliminates 3 here, so that's 1 and 3. No more 3 here. It's a 1-4 pair. 1 eliminates 1 here, so it's a 4-5 pair, which eliminates 4-5 in the rest of the box. So this is 1-8. 4-5 and 1-3 eliminate 4-3, 4. Sorry, 1, 3, 4, and 5 here. So this is 2. 2 eliminates 2 here, so it's 4 and 2. 4 eliminates 4 here, so it's 1 and 4. No more 1s here. 8 eliminates 8 here, so this is 1 and 8. 1 eliminates 1 here, so it's 5 and 1. 4 eliminates 4 here, so it's 5 and 4. 8 eliminates 8 here, so it's 4 and 8. 4 eliminates 4 here, so it's 2 and 4. Okay. 4 eliminates 4 here, so it's 8 and 4. We have 1, 3, 5 remaining in column 7. And this can't be 1. So where's the 1 in column 7? It has to be here. So 1 eliminates 1 here, so it's 2 and 1. 2 eliminates 2 here, so it's 3 and 2. This can't be 1 or 3. 1 eliminates 1 here, so it's 3, which makes it 5. That leaves that as 1 there. Okay, how many 1s do we have? We have 9 2s. We have 8 2s. We know where the last 2 has to be. It's there. 3s, we don't have enough information about 3s right now. 4, we have all 9 4s. 5, in column 4, 5 cannot be here because of 5 in the row, so 5 has to be there. 5 in row 2 now cannot be here because of 5 in the boxes, so that leaves that as a 5, which forces that to be 6. 5 eliminates 5 here, so it's 3 and 5. That gives us all the 5s. 6s available. We have 8 6s. The last 6 is there. 7s. We have 8 7s. The last 7 is there. 8s. We have 8 8s. The last 8 is there. 9 in column 4. This is left of the 9, so that means this can't be 9. So 9 in column 8 is there. That leaves that as a 3. And that's a solution. Congratulations, you solved the puzzle. I hope that this same sum constraint inspires many Sudoku setters, since it definitely allows for various kinds of beautiful logical deductions. That was nice. It was a very nice puzzle. Yeah, it didn't feel like that. It was that bad. Decent amount of arithmetic, but yeah, it is what it is. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.